This is CPM Calculus Chapter 5, number 19. Okay, so for g of x below, write and use your calculator to evaluate a Riemann sum to estimate the area between our function g and between -4 and 4. Okay, for both of the functions below with 16 rectangles. So a quick reminder is that the area, we can find the area using Riemann sums using left, right, or midpoint rectangles. Just a quick review, using left endpoint rectangles, we take sigma, we start at some variable, and we start at 0. We go to n minus 1, where n is the number of rectangles. We go ahead and add up in our argument here delta x times our function, whatever it is, with the input of a, which is where we're starting, over here is a, plus delta x times k. Okay, so this is in general the area, a Riemann sum area using left endpoint rectangles. So both of these problems have the same 16 rectangles. So that's going to tell us that n is equal to 16 because that's the number of regions. We're both of the problems we're looking at the region from -4 to 4. So that's our a and that's our b. And delta x is equal to b minus a over n, which is equal to 4 minus -4 over n is 16. So that's equal to, the negatives cancel out, that's equal to 8 over 16, or 1/2. Okay, so we have n, we have a, b, and we have delta x. So let's go ahead and do problem part A. Our function here is x times sine squared of x. And remember, this sine squared just means x times sine of x times sine of x. That just means two of them. This square is there for notation. It could likely just as well be right here. Alright, these mean the same thing. So the area between our function g and the x-axis between -4 and +4 is equal to, just using the formula we wrote up here, sigma starting at k is equal to 0, but n minus 1, well, n is 16, right? We already said that, n is 16. So this is going to be 15 here because it's n minus 1. Delta x, we said, was 1/2 times f of a, well, a is -4, plus delta x, which is 1/2 times k. Okay, but instead of f here, we have a function which is called g, right? So I'm going to go ahead and write that. This is not f, this is g. So plugging in our function g, the rest stays the same. We have 1/2 times g with this input, which is going to be x, well, that's our input, -4 plus 1/2 k, times sine of -4 plus 1/2 k, and the whole sine is squared. Or I could put this squared here too. It means the same thing. Okay, so to evaluate this, we're going to approximate it in our calculator. So bring out our calculators, turn them on, go ahead and click F3 to calculate, and go down to number 4, which is sum. Right, we're about to calculate the Riemann sum. So now we're going to put in 1/2. I'm going to put in the entire argument here, times -4 plus 1/2 k. The green button and EE will give me, oops, I forgot to put the green button. Green button, oh, not the green one. Alpha and EE gives me k, times sine of, so I'm going to put second second y to get sine of -4 plus 1/2 k. So alpha EE, right? Close the input to the sine, close that. Now take the whole sine and square that. Okay? And just to be safe, I want to make sure my mode is in radians, which it is. Okay? So it's already there. And then I'm going to say the variable I'm using, which is k. comma, and I'm going from k is 0 to k is 15. So comma 0, comma 15. Close that diamond, the green diamond, enter to get approximately the answer, right? And it's approximately negative 1.1455 units squared. Okay? And we're talking about area, so make sure to put units squared. Anyway, I can't really box well on this. Alright, that's better. So let's go on to part B. Part B here we have a piecewise defined function. So it gets a little tricky because we know that we want to look across a region, but we have two different pieces of the function to look at. We're going from -4 to 4, but what you can notice is that for the transition here happens at 0. So we can think of this as doing, for part B, we can have 8 rectangles from -4 to 0, and then 8 more rectangles from 0 to +4, right? That's going to be 16 rectangles in total, and then we can divide this region up into 2 different Riemann sums. So then the area under g of x is just going to be sigma for k is equal to 0, and instead of n being 16, n is going to be 8. So n minus 1 is 7, and instead of delta, well, delta x is still going to be half, but we could calculate that. Delta x here is going to be, well, it's going to be b minus a over n, but now we're going from -4 to 0, so it's 0 minus -4 over 8, which is still 4 over 8 or 1/2. So delta x is still the same. 4 minus 0 is going to be 4 over 8 is also going to give us the same delta x. So for this one we have delta x times f of x, or g, I'm going to say g, of a, we're starting at -4 plus 1/2 k. Okay? Plus, and we're going to do then this one, we're going to go from k is equal to 0 to 7, and delta x is, again, I'm just copying this, times g of, now we're starting, instead of 0 though, we're starting at 0. Instead of -4, we're starting at 0. 0 plus delta x, which is 1/2 times k. Now let's go ahead and plug this in. K is equal to 0 to 7, 1/2. Our function g here is just 3. So g of anything is equal to 3. So I'm just going to multiply by 3 plus sigma from k is equal to 0 to 7, 1/2. Here though, g of, I don't need to write the 0 plus because 0 just is nothing, but it's going to be g of 1/2 k. And I can go ahead and say, well, 1/2 k into this is going to make it 1/2 k squared plus 3. Okay? And make sure you have these parentheses because you want to go ahead and put x to be 1/2 k. Okay? And I think there's a hint in the problem that says, recall that a Riemann sum does not have to involve sigma notation, because we can figure this out without sigma notation, but we can also use sigma notation. So let's go ahead and use our calculator to do this. Again, F3 to calculate, go number 4 to sum, right? We're going to go, our function is just 1 over 2 times 3, right? We don't even have a k, but our variable is k, so alpha k from 0 to 7. So this is the first one. I'm going to do them separately because it's easier to see that way. So that's equal to 12. This right here is 12. And again, we didn't need a Riemann sum to do it, but it's basically finding the area of a rectangle. And this one, let's go ahead and do F3, go to number 4. Now our argument is 1/2 times, open a parentheses, open a second parentheses. Okay, see how there's 2 here, I'm opening them both, right? And then I'm going to put 1/2 alpha k, close the parentheses, square that, plus 3, close the parentheses. Okay? Comma, our variable, we're using k. Comma, we're going from 0 to 7. Go ahead and push the diamond green button and then enter. And we're going to get plus, this one was 29.5. So we add those together. We're going to have 12 plus 29.5. And we get 41.5. And again, it's unit squared because it's area. Okay? So this is important to know how to find the estimated area using some number of rectangles, right? And don't forget this. This is in general using left endpoint rectangles to find the area. Alright, so that's going to end for us CPM Calculus Chapter 5, number 19.